All right, you made it through your first unit in trigonometry. And now we're going to start the second one. So 9.1 is reference triangles and reciprocal trig or trigonometric functions. So what we learned in Unit 8 is actually one of the sections in Unit 8 was we talked about sine, cosine, tangent kind of stuff. Now we're going to start using that a lot more in this unit and in subsequent units as well. Pretty much the rest of the year, we're going to be using sine, cosine, tangents, and what we call the reciprocal trig functions, which we'll get into that a little bit later. All right, so we have this thing called a unit circle. Basically what it is, it's a circle with a radius of 1. So here's my circle, here's my x and y axis. If from the center of the circle I draw a radius out, okay, that radius is actually going to be 1. And if I make a triangle with that radius, where, oof, that was terrible. Hold on, let me fix that thing. So if I come down, that's terrible too, but that's a 90-degree angle. And if I move over, right, from the center to this dot here, this line here, it's going to be x. And then if I go up, that's going to be y. So this point that is on the circle is actually going to be x comma y. All right, that's pretty simple. I don't think that's that difficult to understand. I'm moving over x and up y, so that point is x comma y. So in this unit circle, this angle down here is called theta. We've dealt with theta before. Okay, and we're going to use this in terms of reference triangles. So this is kind of our reference triangle diagram here. And we're going to do the same thing. So I'm going to draw my radius. In this case, it's r, because we don't know if it's 1. It could be 2. It could be square root of 3. We don't know what the value is. I'm also going to make my triangle down. And again, I have my 90-degree angle. Therefore, this is still x, and this is still y. And this point here is now x comma y as well, right? That's the same. It's the same value. And of course, we have our theta right there. Now, if I go back to my unit circle here, so this is the true unit circle. Okay, this is what we're going to have to be dealing with a lot. You might or might not have to memorize it. We'll see how I feel on any given day, but for the most part, this is going to be something that you're going to need to know. Now, if I want to find this value here, okay, from this theta angle, this is the adjacent. We know the hypotenuse is 1, so the adjacent would be cosine, right? So I could say the cosine of theta is equal to the adjacent over 1. Well, because it's over 1, that just means that the cosine of theta is really equal to x. So in the unit circle, in trigonometry, this x is actually cosine of theta. Okay, x stands for cosine. Now, if I want to find this value of y, that's of the same theta, that's opposite over hypotenuse. So that's sine of theta is equal to y over 1, which then the 1 doesn't matter. So sine of theta is equal to y. So the y value, I'll do it up here, is actually going to be sine of theta. So this is pretty interesting that x comma y is really cosine theta comma sine theta. That's pretty interesting, honestly, because it's saying that any x is really cosine and any y is really sine. So that's kind of awesome. And therefore, then, the tangent of theta is really going to be just y over x. Whatever the y is, whatever the x is, just divide those two out. So that's pretty amazing right there. All right, fantastic. So we're going to use all of this information to deal with reference triangles and to try to find the other values of what x, y, and r actually are in relation to the unit circle. So let's get a move on. All right, here we go. So now we're going to start using some reference triangles. As you can tell, this diagram here, this diagram we'll do in a second, but this diagram here is not going to be a unit circle because we do not know the value of this line here from the center to the point. we're going to assume that it's not 1. It's not going to be 1, but we're going to assume it definitely isn't 1. So what I want to do is I want to take this angle that is in standard position. Remember, standard position's right on this x-axis here, right at 0 degrees or 0 radians. And I want to take the point that is drawn, and I want to make a 90-degree angle with the x-axis. So there's my 90-degree angle, and then there's my triangle right there, okay? And what I want to do is I want to put these numbers in their spots. So this is the x value, so the x is left -3 or left 3, and then up 4, so this is a 4 right there. And my goal is to find the sine of theta. Well, this is theta because that's our triangle, that's our angle. The angle is always touching the x-axis. So if I have a triangle that goes up here, this is going to be theta. If I have a triangle that goes out here, again, that's going to be theta because it's touching the x-axis. So that might be something you need to kind of make note of, maybe over here in the margins, theta always, and then you can figure, and you can write the rest out. So it's sine of theta, right? So sine of theta is equal to what? It's equal to opposite over hypotenuse. Well, the hypotenuse is right here. That's R or H or C, whatever you want to use it as. These are right triangles. Therefore, we have a couple different things we can do. We can use what we call the Pythagorean theorem. Okay, you might remember this from 7th grade, 8th grade, 9th grade, whatever geometry class. Okay, you've done Pythagorean theorem a lot in life. Remember, it's a squared plus b squared is equal to c squared. So how do I do this? Well, if I want to find r, because it's a right triangle, I can, or if this is c, right? So I can find this by plugging in. So it'd be 4 squared plus -3 squared. Please put -3 in parentheses, otherwise it's going to be a wrong answer. Please make sure you do that. Equals c squared. 16 plus 9 is equal to c squared. And so then this is going to be 25 is equal to c squared. C is equal to 5. So that means this here is equal to 5. Therefore, the sine is opposite, which is 4, over the hypotenuse, which is 5. Okay? Great, great, great. That's our sine of theta. For the second one over here, t is -3, -6. So there's a point at that particular area in this graph. Well, -3, -6 is going to be down here somewhere. So we'll say we're going to be this point here. Okay, so there's my right triangle. There is my right. I'm down -3, and I'm down -6 and over -3. And I want to find the cosine of theta, which, remember, the theta is touching the x-axis. Well, what's cosine? Cosine is adjacent over hypotenuse. So I want to find the hypotenuse, or r, or c, or h, whatever you want to label that as. So I'm going to go back to my handy-dandy Pythagorean theorem. -6 squared plus -3 squared is equal to c squared. This here is 36 plus this is 9 is equal to c squared. This is 45 is equal to c squared. And therefore, c is equal to the square root of 45. Now you might be like, yeah, I'm good. I got my answers. Well, that's not right. Remember 45? I'm going to do it both ways, but 45 is really 9 times 5. So the square root of that is really 3 square root of 5. Or you can say this is 3 times 3 times 5. Remember, I can circle 1, cross 1, and this pops out. Okay, so you still get the same answer. Therefore, now I'm going to rewrite my answer. So adjacent, okay, adjacent is -3, boom, over what? It's over 3 root 5. Okay, 3 root 5. But we can reduce this. They both have 3's not in the root. I cannot divide by a root, but because the 3 is on the top and in front of the root, I can divide. So that's really -1 over root 5. Now, we're going to go back to pre-calculus. We're going to go back to algebra 2, and we're going to rationalize. Remember, rationalizing, we multiply by the conjugate, which is square root of 5 to the top and bottom. So now I figure out my answer is going to be Negative 1 times that is negative root 5 over root 5 times root 5. We keep what's inside. This is the number 5. So this is our better answer. This is better, but I am okay if you leave it this way. I'm okay if you leave it this way. Dang, that's like Dr. Seuss up in here. What up, Dr. Seuss? I could write children's books too and make up my own words. All right. So I'll accept either, but this is better when you get to college and everything. This is probably what they're going to care about, but I am okay leaving it that way. All right. So here we go. Since given theta is in quadrant 4, so here is my XY graph. Quadrant 4 is over here. Something we got to know. Remember, this is 1. Sorry, oops. This is 2, and this is tree. And so then I have a triangle somewhere. I'm just going to put a dot. I'm going to make a triangle. These triangles are not drawn to scale, so don't worry about trying to get them perfect. It's not a big deal. Okay, and so this is theta here. I want to find cosine of theta given that sine theta is negative 3/5. So what does that mean? Okay, the hypotenuse, okay, the hypotenuse is always going to be a positive value. It's always positive. It has to be, because when you do the Pythagorean theorem, it has to work out that way. So remember, the sine of theta is actually opposite over the hypotenuse. So this 5 is going to go here, and because it's positive 5, okay, that's what's going to go there. It doesn't matter if it's negative fraction, it's positive there. Well, this 3 is going to go right there, because the sine, remember, is opposite, so that's where it's opposite there, okay? So now I'm going to work backwards to find the cosine, because that's adjacent. All right, adjacent is going to be this x value right there. So I have to work backwards. So I have c, which is 5 squared, is equal to negative 3 squared plus b squared, or x squared. You can use that variable, doesn't matter. So 25 equals 9 plus b squared. B squared is equal to 16. Therefore, b is equal to 4. So this value is actually 4. So now the cosine of theta is equal to 4 over 5. 4 over 5, because 4 is positive, 5 is always positive, and therefore I get that. Now, I do not want you to. I don't know if that makes sense. Do not put into decimal. Like, I don't want you to put this is 0.8. I know it's 0.8. I don't care about 0.8. 0.8 doesn't tell me anything. You will be marked wrong if you put 0.8. Leave it as your fraction. If it can be reduced, like if it's 12 over 15, then sure, go ahead and divide that by 3 and put 4 over 5. Fantastic. But do not ever, not ever, once, ever, not ever put it as a fraction. I'm sorry, I said it wrong. Don't put it as a decimal. Okay, do not put into decimal form. Let's go on to some reciprocal trigonometric functions. All right, let's get it. So reciprocal trigonometric functions are as follows. We have these 3 on the left. We've done sine, cosine, tangent already. We've probably done these ad nauseum, so you're probably a little tired of them already, but they're easy, so it shouldn't be that big of a deal. Remember, sine of theta is equal to opposite over hypotenuse. Okay, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so those are easy. Now, reciprocal trigonometric functions are basically saying, okay, I'm going to take what is sine, and what this is called here is called cosecant. Okay, cosecant. This one here is called secant, and this one here is called cotangent. All right, we need to get that down pat, the lingo. All right, and that's going to be great. So the cosecant of theta is the reciprocal trig function of sine. So here's how I remember this. Sine goes to C, so S to C, C to S. Never S to S or C to C. Okay, so cosecant does not go with cosine, and sine does not go with secant. S to C, C to S, they're switched. They're never the same. And then tangent and cotangent go together. All right, tangent and cotangent. I don't know why they do cosecant and secant, but is what it is. You know, this has been around for hundreds and thousands of years. So you just kind of deal with those old Greeks or Egyptians or whoever invented all this stuff. I don't know. I'm just living the dream. Okay. So reciprocal trig functions basically is what you're doing is you're taking what the original function is and you're just flipping the value. So this is actually the hypotenuse over the opposite. The secant is going to be the hypotenuse over the adjacent. And then the cotangent is just the adjacent over the opposite. All right. Now, you will see that here, but you might also see something else. Okay. So cosecant is actually, another way to think about it is 1 over the sine of theta. So 1 over the sine. So I'm flipping it. So it's really sine over 1, but reciprocal is I'm taking this and I'm taking my denominator, putting it up, my numerator, putting it down. I'm flipping it. So that means the secant is 1 over the cosine of theta, and then the cotangent is 1 over the tangent of theta. So this is another way to think about it that you probably have to know this. You'll be using these notes in a little bit. I mean, it's not that bad. You just got to kind of think about and remember, kind of memorize them a little bit. Let's get some examples here. So from theta, sine of theta is opposite over hypotenuse, so 5 over 12. Okay, that was, oh, I'm sorry, 5 over 13. Oof, 13 is the hypotenuse, not 12. Cosine is adjacent hypotenuse, so 12 over 13. Okay, tangent is going to be 5 over 12, right? Opposite over adjacent, 5 over 12. Well, if these are reciprocal, all I'm doing is flipping the fraction. So cosecant is going to be 13 over 5. And secant is going to be 13 over 12. And cotangent is going to be 12 over 5. All right, that's easy peasy, lemon squeezy. Let's move on. All right, so for this one, if I'm given some information and I have to find the sine of 8, or if I know the sine of pi or sine of theta is 8 over 17, I got to find all 6. Okay, so I have 6. Remember, sine, cosine, tangent, cosecant, secant, and cotangent. Those are the 6. So I have to draw a figure. If I'm given this, what quadrant is that in? Well, this is 0 or 2 pi. This is pi over 2. This is pi. And this is 3 over 2 pi. It says it's in between pi over 2 and pi. So that means we know that it's in the second quadrant. Okay, so I'm going to plot a point. I'm going to make a triangle down with the origin. Here is theta, and we are good to go. So it says the sine of theta is 8 over 17. Well, 17 is the hypotenuse. Remember, hypotenuse is always positive. 8 is the opposite, so opposite is over here. I have to find the x value. Okay, so let's do that. How do I do that? Oh, wait, I use the Pythagorean theorem. 17 squared is equal to 8 squared plus x squared. I'll use x instead of b. That's fine. Doesn't matter. 17 squared is 289 minus, equals 64 plus x squared. X squared is equal to, looks to be 225. And x is equal to 15. Now, because I'm going left, okay, this is in the negative section on the x. This is actually going to be negative 15. We've got to make sure we get that right. Think about where the triangle is located and make sure we have the right units on the x or the y. The hypotenuse is always positive, so that doesn't matter. Now we got to find all 6. So we have sine of theta, we have cosine of theta, we have tangent of theta. Let's do those first. Well, sine, I already got. It's 8 over 17. Fantastic. Pretty easy. Cosine, adjacent, negative 15 over the hypotenuse. Tangent is the opposite, 8 over the adjacent, which is negative 15. You can put the negative up if you want to, but that's not that big of a deal. Cosecant is the next one. Cosecant of theta. Cosecant of theta is just sine flipped, so that's 17 over 8. Cosine, the opposite is secant of theta. The opposite is going to be 17 over negative 15. All right. And then tangent would be the cotangent or the cot of theta, and that's going to be negative 15 over 8. All right, fantastic. Those are all 6. Okay, again, not bad. This is a pretty easy section. Oh, wait, until we get to this problem. I'm just kidding. Not a big deal. Okay, here we go. So what quadrant can theta be or lie in if all of these conditions are met? Okay, all of these conditions are met. So sine of theta and cosine of theta have to meet these requirements. So where does the sine of theta greater than 0? This is where the y's are greater than 0, but the x's are less than 0. Okay, so let's think about this. Well, this is quadrant 1, 2, 3, 4, 5. Everybody get in the car and go for a drive. That used to be like an old Mazda commercial. I don't know why, but that kind of rings a bell. I don't know. Anyway, so in quadrant 1, what is the x? Well, the x is positive. What is the y? The y is also positive. In quadrant 2, the x is negative. The y is positive. In quadrant 3, both of them are negative. Oops. Sorry, let me fix that. Negative. There we go. And in quadrant 4, we have positive x, but a negative y. All right, fantastic. This one looks like somebody got punched in the face. Quadrant 2 and quadrant 4. Quadrant 2 looks like, well, quadrant 3 looks like somebody's sleeping, and quadrant 1 looks like maybe they're awake. I don't know. It just looks like faces to me. Anyway, so sine of theta is greater than 0. That means that it's got to be positive. Okay, so that means y is positive, which is in quadrant 1 and in quadrant 2. Quadrant 1 and in quadrant 2. Cosine of theta is less than 0. Okay, so cosine of theta is in less than 0, which is in quadrant 2 and quadrant 3. Quadrant 2 and quadrant 3. So where do they both have things happening? So sine of theta is greater than 0 and the cosine of theta is less than 0. Both happening in quadrant 2. So that is your answer. Okay? So sine of theta and the tangent of theta have the same sign. So sine of theta, we already have that stuff down. But tangent of theta, remember, is equal to y over x. So if I come back to my graphs here, tangent of theta is going to be positive in the first quadrant. It's going to be negative in the second quadrant. It's going to be positive in the third quadrant, because if I divide these, I get positive. If I divide these, I get negative. All right? So where do they have the same sign? Well, they have the same sign in quadrant 1. They also have this. No, they don't have the same sign there. Duh. They do not have the same sign there, but they do have the same sign in quadrant 4. So 1 and 4 are your answers for part B. Pause a second real quick and try to do part C. All right, cotangent is just taking the tangent and flipping it. So regardless of everything else, I know that the cotangent and tangent are going to have the same signs in each of the same quadrants, because if I take a positive and I flip it, it's still going to be a positive. If I take a negative and I flip it, it's still a negative. So the same signs exist in all quadrants. Secant is 1 over cosine. So it's whatever the cosine is, just flipped upside down. So if the cosine is positive in quadrant 4, guess what the secant is going to be? Oh yeah, positive. So those are all the same. So I'm going to see where those two do not have the same signs. So in quadrant 1, this is the same as this. So they're the same, so we don't need that. They're also the same there. They are different here, so in quadrant 3. And they are different here, so in quadrant 4. Okay, those are my answers for that problem. All right, that concludes the first video in this unit. It's a little long, but hopefully the explanations are pretty easy and you should be able to fly through the packet. All right, questions asked, but other than that, deuces.